Professor at Tamil Nadu Agriculture University. He's a fellow of National Academy of Agricultural Sciences, and he helps us quite a bit on the editorial board of Agricultural Research Journal, which is published by Academy. So, Professor Viswanathan, if you want to add more for your introduction, please do that and start your presentation.
Thank you, sir. You have done more than what I proposed to do that. So, good morning, everyone. So, food industries, especially the food industries in India, they work 24/7. Whether it is any national calamity or COVID, or it is a heavy rain or hurricane, but we never go without a day we get a milk packet at our doorstep. That is an example how our food industries work, irrespective of any disturbances they get. Food safety, how best it is not doing any harm to the consumer. So the concept is through the hazards, hazard analysis and critical control points, where the hazards in the process to preserve the food materials are identified and eliminated. We are following or adopting different instrumentation facilities to measure and control the various parameters that are linked to the analog system and digital then recording system as well. Now we are going for the automation, fully automatic, where though it reduces the manpower required in the production line, it ensures the precision in the applications. Precision next. These are all some of the instrumentations we followed and also still following. And yesterday we had more number of presentations with respect to the implements and water saving concepts. Today something on the post-harvest. We are talking about drones, mainly for the spraying. Drones, they have applications in other aspects also to judge the crop maturity. Whereas we look at the crop maturity, whether uniformly it has attained maturity. Looking at the pest attack, sir has rightly mentioned about my editorial contribution in the journal. I received one of the manuscripts from our engineering institutions. They have developed one app, takes the picture of the field with the pest, then it is analyzed and judges what is the type of pest and the recommendation is given like that. Suppose we do the harvesting and windrow the crop and allow it to dry, you can judge really whether the drying of the crop has been reached to go for the I think the crop is viewed aerially for judging its quality. Next. There was a refractometer. Earlier, we used to have the handheld refractometer. You can drop off the sample. You move out of the room to view the sunlight to judge the TSS. Now, see the digital one, where even at room light it works. There are other various instrumentations used in the processing industries for measuring the gas flow or the flow of the juice and other pulp materials, velocity of air, measuring the flow rate, the older technologies, venturimeter. Next. Then machine vision system. It plays an important role. If food industries also. Where if you see in a production line in a bakery, something gets charred also, the top layer, when exposed to the temperature. Temperature and time are the critical points in the bakery. Sometimes it gets charred, so how to remove those charred ones. Then sorting the fruits and vegetables, especially the fruits, based on the ripeness, the color. It's the color. So if it is not to that level of color, they are removed or sorted in the production line. These are some good examples of automation in the food industries. Next, please. Then we use the sensors, starting from the sensors for the gases, sensor for measuring the pH, acidity, sugar content, like that. They help in adding or removing those constituents during the production process. Next. So digital technologies, they are with a higher level of accuracy, so useful in automation. They result in precision control of the parameters. Next. So again, the advantages are reducing the wastage and also reprocessing. Suppose something goes wrong, the entire batch will be subjected to reprocessing. That can be avoided or minimized when you go for automated system to control the process parameters. It improves the worker safety. So worker need not be stand near the hot pan or in the process line with anything hazardous in nature. So they can be aware and monitor whether the process is as per the schedule, and through automation that is made possible. The different tools used in automations. Next. So again, the same things with reference to different types of industries. Next. There are some bottlenecks. Again, maybe the initial investment. And this machine vision system where they are divided into acceptable and to be rejected. Next. Again, another example of machine vision system. Next. So this automation, how it increases the production, productivity, increases the profit, and also ensures the quality. Next. It's one of our experiments in our laboratory using a machine vision system to grade according to ripeness. And also we tried to develop based on the size, but we could not able to succeed because the requirements are different. Next. Then machine vision system in filling and packaging. So to ensure that the filling is done up to the level it requires, or it is not having any hazards that will be floating at the top of the package. So it is ensured through this machine vision system. Next. Then about the gases. When we use the different compositions of gases for the use in storage, like oxygen, nitrogen, carbon dioxide, they are all mixed in different proportions. It is done using the sensors and automatically controlled. In the drive systems, we use motor with the belt drive, chain drive, and later we started using the gearbox. Now the motors with the gear motors, called the gear motors, are attached to the gearbox. For an example, the process of making the jam, we take the fruit juice and all the ingredients are put. It will be with the TSS of around 4 to 10 degree breeze, and that will be solidified by the application of heat up to 65. When the solidification increases, the stirrer used, it needs more power. Ultimately, the power of the motor is made to that torque required at a higher bricks level. So that is a problem in the food industries where we need some mechanism so that the power requirement can be reduced and it synchronizes with the torque requirement. So that is one thing. Then in the case of the online sorting, where the machine vision system judges whether it has to be accepted or rejected. But the process of rejection or accepting takes place after a certain travel path. That is the response time. I don't know the exact terminology in automation. So if the time is made reduced, it is done quickly, the product need not travel for say for about more than 1 or 2 meters. So that space can be reduced in the industry, may increase the production capacity. With savings in space, the industry can go for one more line to increase their production. So the productivity is increased, the profit can be increased. The production cost will be reduced. So these 2 points I just wanted to highlight to the group working on automation so that the industry will get the advantage of less power and reducing the response time. So hereafter I was asking maybe not another hand.